All right, so we are starting chapter 4 today, which is about exponential functions. And for exponential functions, we are going to be using these models to solve problems. Okay, we are also going to be graphing these functions, which you guys did yesterday. Okay, and then we are going to come back to this after we look at what you guys did yesterday for example 1. Okay, so you had to graph the function. You could use your graphing calculator, and then you stated the domain, the range, and the asymptote, and you used interval notation. So this is something that you have done before, which is why I had you do this on your own. So when you're doing 10 to the negative x, when you plug that into your graphing calculator, if you guys can write down your table with me as we investigate this, you have 10 to the power of negative x, okay, which would be the same thing as 1 over 10 to the x power. So what's happening is when you're plugging those in, if you get a negative, when you go to the table and you see these values like this 0.1, this 0.01, okay, 0.1 is in the tenths place, so that's going to be 1/10. 0.01 is in the hundredths place, so that would be 1/100th. So I want you to keep these in mind. You are going to be able to use your calculator for these graphs, but when we study exponential functions, we are going to go back and talk about, hey, when you have a negative exponent, that's 1 over 10 to the first. Okay, when you have 10 to the negative 2, it's 1 over 10 squared, which is going to be 100. Okay, and then these numbers got large really fast, so if you just wanted to make yours to 10 to get that general shape, you absolutely could do that. And then you should have y equals 0 as your asymptote there. Okay, so your domain is going to be all real numbers. Remember when you're doing the domain, there are 2 things we're looking for mainly. That's fractions, and that is even roots. So if there's no fraction, okay, where the variable is in the denominator, you don't have to worry about that. Okay, if there's no even root, then we don't have to worry about that, all real numbers. Okay, to do the range, we look at the graph. All the values are above this. Your graphing calculator is eventually going to round something to 0, but do you see these 1e's to the negative 15th? Okay, that's 1 times 10 to the negative 15th. So it's a decimal, 14 zeros, and then a 1. Okay, so it is getting really, really close to 0, but it's not going to reach it. And that's just because there's nothing you can plug in that would make this 0. Do you guys remember what anything to the 0 power is? 1. Okay, good. All right, so this is going to be your horizontal asymptote. Okay, these are the points I used on my graph. Okay, and then for the second one that you guys completed, you had 5 to the power of negative x, and then you have this plus 1 here. So when you guys looked at your graph, I'm gonna go back to my standard window. Actually, I can also do the negative 5, 5, because that's what your grid was, and then you could choose to change that if you wanted to. Okay, so for this graph, we can see it's getting closer and closer to 1. That's because y equals 1 is your horizontal asymptote there. I thought I had the negative 226, and that was really far up, so I concentrated on these 4 points to put on my graph, and then I understood that this was going to go up steeply. Okay, and again, I wrote these as fractions. You can write them as your decimals. So your calculator here is rounding it to 1. I know that's a little bit confusing because it does round because the numbers get so small, but it is never going to cross a horizontal asymptote, okay, in an exponential function. So with rational functions, they could cross, okay, with a horizontal asymptote in an exponential function, it will not cross. So that's why our range here is 1 with a parenthesis and not with a bracket. Okay, and then the horizontal is y equals 1. And again, it's an equation, so you do want to have your y equals there. Okay, what questions do you have for me in A or B? Yeah, if you don't have a calculator to figure that out, you can always just plug in any values for x. So if you plug in 0, anything to the 0 power is 1. 1 plus 1 would give you 2. If you plug in a negative and it's already negative, it would be 5 to the first, which would be 5 plus 1, that would be 6. 5 to the second, 25 plus 1 would be 26. And then I wrote that as a fraction because if I plug in 1, this would be 1/5 plus 1. So I just wrote it as 1 1/5. Yeah. All right. And then the last one, again, I did that same pattern. Okay, we have all of these decimals here because it is going to follow along that line. And then at 4, you have 2. At 5, you have 3. So this is not going to be as steep here. If you were to graph more than these 5 here, okay, you would get a steeper curve. Okay, but I gave you the 5 by 5 grid, so I'm okay if you just graph this part. Okay, you can also do the 10 by 10, okay, which you're going to see more of that curve there. All right, so if you went by 2s, I actually think that that's better for this. I think most people went by 5s, but you do have that option. And again, you have that y equals 1 as your horizontal asymptote. That's what it's getting closer to. Domain, all real numbers. And then everything is above 1, so it's 1 to infinity for the range. Okay. If you have a flip, that is going to change the range, and that's what I asked you to think about in those questions above. So we are going to look at those. Okay, I'm going to show you this graph, and it says, after completing example 1, answering the following. So how do you find the horizontal asymptotes? There's 2 ways that you can do this. In both of the graphs, you can find the line the graph approaches. So it's getting closer and closer to that value. Okay, and then you may have also noticed it is going to be equivalent to whatever is added to the exponential function. Okay, so the value that is added or subtracted to, and we'll just say a to the x, that's the exponential part. Okay, that is the horizontal asymptote. Okay, now I said if there was a reflection of the parent graph, how would that affect your range? Okay, so the first thing we're going to look at is if one of these was reflected over the x. So let's just draw that. Okay, so if there was a reflection over the x-axis, okay, you would have something that looked like this. You can just draw a rough sketch there. And in that case, your lowest value would be negative infinity. Okay, and then your highest value would be 0. Okay, so if the graph is going downward, the lowest value would be negative infinity. The highest value would be 0. Okay, if it was a y-axis flip, okay, again, we'll just look at this part A. If I were to flip that over the y, it would just be going the opposite way. And in that case, the range would stay the same. You would still have 0 to infinity. 0 would still be the lowest point, okay, and then infinity would still be the highest point. Okay, so your exponential functions are going to have this form of f of x equals a to the x. Okay, sometimes we're going to have another value that goes with it. Okay, right here in this information box, they tell you the domain is all real numbers. Okay, so your domain is negative infinity to infinity. Okay, this is for the parent function. The parent function range that you see below is 0 to infinity. Okay, that can change based on reflections. Okay, and that line y equals 0, which is the x-axis, is the horizontal asymptote for this function. Okay, so these are going to be your shapes. Whenever you are doing the asymptotes, okay, I want you to make your dashed line. You can use a highlighter and then just label it. So in this case, it would be y equals 0. Here you have y equals 0. Okay, and then they give you a few stipulations at the bottom. This is something you might remember from before. If you have a is greater than 1, okay, the type of exponential function, it is called a growth function. Okay, when you have exponential growth, the base or the absolute value of the base is greater than 1. Okay, and then when that happens, okay, it either approaches infinity or negative infinity on the right. Sometimes what people forget is something can grow in the negative direction. Okay, so it can grow positively or it can grow negatively, right? Your money can grow positively, or if you're in debt, it can grow negatively. When you have decay, the base is in between 0 and 1. Okay, so 0, and again, this is your absolute value. The negative is going to represent a reflection. Okay, so in that case, it approaches an asymptote on the right. Okay, in both of these cases, it approaches 0. Just depending on what the asymptote is, it might be a little bit different. So here, this one approaches 0 on the right. This one is approaching infinity. All right, so we are going to use this information to help us with our future problems. Okay, 4.1 and 4.2 are actually very closely related. Okay, and then once you have that down, I want you to go to example 2, since we've already done example 1. Read through the story problem. I want you to see if you can come up with a function that models the number of rabbits after T years. I see a lot of good numbers happening in our estimates. Okay, so I see a lot of you doing a nice job incorporating the 200. So that's your initial value. Okay, whenever you create a function, when you are plugging in 0, your final answer should be 200. So with your equation that you came up with, I want you to plug in 0 and see if you get 200. And if you plug in 1, what should you get? You don't have to write this part down. I just want to model this for you. Okay, so your input, your output. Initially, there were 200. Okay, after 1 year, how many? 400, because it's doubling. After 2 years, 800. After 3 years, 1600. Okay, so see if your equation passes that test. So let's keep in mind the exponential function they gave us was just f of x equals a to the x power. Okay, if I did 200 to the 0, that would just be 1. I don't want that. Okay, if it's doubling each year, doubling has to be the base. Okay, so what we're going to use is you can use this a times b to the x as your equation. You guys might remember this from a previous year, you might not. This is your initial value. Okay, and this is your base, which is the ratio. So if it's doubling, okay, that ratio is going to be 2. Okay, so if you have y equals 200 times 2 to the t, let's see if that is going to satisfy these values. So when I plug in 0, do I get 200? 2 to the 0 is 1. 1 times 200, yes. If I plug in 1, okay, 2 to the first is 2. 2 times that, 400. I know when I plug in 2, I should get 800. 2 squared is 4. 4 times 200. And I always go to 3 because 0, 1, and 2 have special properties. And then 8 times 200 is 1600. Okay, so yes, that does fit the model. Okay, estimate the population after 7 years. Once you have a model, you can go ahead and calculate. Okay, and don't worry, you can use your calculator for this. If you know that 2 to the 5th is 32, and you double that, you get 64. You double that, you get 128. Okay, so 2 to the 7th is 128, and then multiply that by 200. Okay, and then we will put our units with that. So the population be 25,600 rabbits. Okay, so that common model that we are going to write down for an exponential function is y equals a times b to the x power. Okay, a is the initial value, and we call b the base, which is the ratio. Okay, so if it's tripling, your ratio would be 3. If it's quadrupling, 4. Okay, one of the main applications of exponential functions is going to be computing interest. So for compound interest, we're going to use the formula a of t equals p times 1 plus r over n, okay, to the nt power. Okay, and then one thing you need to remember for this is do not round until the last step. Okay, so there's going to be opportunities where you have to use the answer that you get. Okay, so A of T is the amount after the years. That's your total. Okay, that is going to be in dollars. Same thing with the principal amount. Okay, the principal is your initial value. Okay, the interest rate per year is a percent written as a decimal. So we are going to have to convert that. And then N is the number of times interest is compounded per year. So we're going to talk about some different cases with that. And then T is the number of years. So if they gave it to you in months, you would have to convert that to years, which is something you may have done previously, but this year they are mostly going to give that to you in years, okay? So if 2,500 is invested in an interest rate of 2.5% per year, compounded daily, find the value of the investment after the given number of years. Okay, so we have this 2,500. That's what's invested. That is our principal. The interest rate, which is the 2.5% per year, when you're converting this to a decimal, because percents are out of 100, you just move the decimal back 2 places. Okay, so this would be 12.025. Okay, that's 2.5%. If you just did 0.25, that would be 25%. Okay, and that is going to be your value for R. The last thing they tell you is it's compounded daily. So if it's compounded daily, it says how many times it's compounded per year. You just have to ask yourself how many days are in a year, which is going to be, we're going to use 365. Okay, and then we can find the investment after A, 2 years, and after B, 6 years. Okay, so for this one, your T is 2. Okay, so your A of 2 would be to plug in your 2,500, 1 plus 0.025 over your value of N, which we said was 365. And that is raised to the power of 365 times T. Okay, now whenever you have money, you are always going to round to the nearest cent. Okay, it's not going to tell you that. You need to apply the logic of money here. Okay, so that would be 2 decimal places. So I want you to practice plugging that in. And then go ahead and set up your A of 6. You can plug this all in at once. Let me see if you need to put parentheses around this fraction. If yours doesn't automatically do the exponent, okay, then you will need to put that in parentheses. Okay, so $2,628.17. You can also do this in parts. If you have the same setup, but you're only changing the years, then I recommend, if your calculator allows it, that you highlight this and just change this to the 6. Okay, and then if you aren't getting that, as we'll come around in a little bit, let me help you make sure that you can get that on your calculator. Okay, and then I want you to read through example 4 and label everything given to you with the variable. All right, so for this, they give you the present value. So it says find the present value. So what you have to find is P. So you are going to be solving for P here. It says find the present value of 10,000 if interest is paid at a rate of 7%, compounded semi-annually for 4 years. Okay, and when you're trying to decide what something means, like semi-annually, I want you guys to think about like the prefix of words and how we can relate that to some things, because that's just going to help you remember. Okay, so we have to find P, which means find the present value of 10,000. This is going to be your total. This is going to be your A of T, the amount in the account. If interest is paid at a rate of 7%, so 0.07, semi-annually for 4 years. Okay, I remember semi-annually because I like to go shopping and people have semi-annual sales. Maybe you can remember it because what does the prefix sem mean? Half, because how many semesters do we have in a year? So if we have 2 semesters, the semi-annually is going to be twice a year. Okay? All right, and then we are going to set up our equation. So for A of T equals P, 1 plus R over N to the NT. I have 10,000 is equal to P, 1 plus 0.07 over 2, and then 2 times 4. Okay, so when you're simplifying, we're going to follow the order of operations. So we're going to start inside the parentheses. We're going to start inside the parentheses there. Okay, so I'm going to do 0.07 divided by 2 plus 1. Again, we are not rounding until the end. Okay, when you're doing this, you can raise this to the 8th power and find that decimal, or if you're solving for P, you're just going to be dividing by 1.035 to the 8th. So if you want to divide to find what the value of P is, you can absolutely do that. Okay, so we simplified here, we did not round. So then I can do 10,000 divided by 1.035 to the power of 8. Okay, and then this is 115. So when you're doing this, you have to look at this to decide what to round to. So it's $7,594.12. That's what it is rounded. Okay, and then if an investment earns compound interest, then the annual percentage yield is something that we're going to find. Okay, this is called the APY. So the annual percentage yield. Okay, so the annual percentage yield, okay, is going to be a percent. Okay, so the annual percentage yield is going to be what is called the simple interest rate that yields the same amount at the end of 1 year. Okay, so simple interest is going to be 1 plus R. Okay, the way that this is constructed is the 1 comes from 100%. That's how you write it as a decimal, 1.0. Okay, and then the R is going to be your rate. Okay, and it is at the end of 1 year. That's going to be your value for T. So when it says to find the APY for an investment, we are going to be using 2 things. Okay, so the first thing we're going to do is our compound interest formula. So it earns interest at a rate of 4% per year, and then it says it's compounded quarterly. Okay, so we know our R value is 0.04. Quarterly, how many quarters are there in a year? 4. And then anytime you're finding the APY, your T value, the time is going to be 1. Okay, you are not going to have a principal value. So when you are setting this up, you are just going to say your A value or your A of T is equal to the principal times 1 plus the rate over the number of times it's compounded, and then N times T. I'm just going to give you a second to look at how that relates to your original equation there, okay? All right, and then once you have that, we're going to calculate this part of it. Okay, so we have 0.04 divided by 4, which is 0.01. When you add 1 to that, it's just going to be 1.01 to the 4th power. Okay, we are going to calculate that, 1.01 to the 4th. Okay, and I want you to write down this whole decimal for this. we're going to do some computing. So what you get here is the simple interest. So in order to find the simple interest rate, we already talked about how the simple interest is just 1 plus the rate. Okay, the 100% of the money you put in plus the percentage that yields. So if you are going to set these equal to each other, the 1.04060401 equals 1 plus r. If you're solving for r, what am I going to do to both sides? Just subtract 1. Okay, and then you are going to write this as a percentage. Okay, so to write it as a percentage, the easiest thing to do is just multiply by 100. So you minus 1. Okay, and then you can round to the nearest hundredth. So 4.06% is the simple interest rate. So see how it said it was a rate of 4% per year? Okay, you actually yield like the 4.06% because of how it's compounded. Okay, so you're going to solve to find the rate, and then anytime you find the APY, we're going to write that as a